Um, Hi everyone, I'm Arjun. I'm one of the founders of Connext. Um, we originally started out, so we've been around for a while. We started in like 2017. We originally started out doing something a little bit different. That's actually how I met Mason back then, I believe. I think it was like 2018. And when we started, we were building like easy way for users to get onboarded onto Ethereum using credit cards. So basically, just purchasing credit cards directly with tokens, purchasing tokens directly with credit cards. We actually made a decent amount of headway into that, going like trying to be set up as like a payment processor with Visa Mastercard, and we found that there was just a bunch of like overhead in that direction, which didn't yield a lot of benefit for us. So like we would have ended up competing with things like Wire or MoonPay, except that we wouldn't have had the money transmission licenses. And so we wouldn't have had the capacity to decide our own risk. We would instead have had our risk be decided by like bank partners for whom any sort of token was like just hugely taboo. And so we kind of decided to pivot. We found that a bunch of our users were actually struggling. This was like early 2018, so they were all struggling with scalability at that time too. And so we pivoted to building like payment channels just because at the time that was what was most needed for our own users. So yeah, fast forward to today, we are a state channel network on Ethereum. What that means is it's very. I've been told that you guys have familiarity with Lightning, and so it's a very similar concept to Lightning. Rather than making transactions on chain, you move them off chain and have them happen peer to peer. There's some good and some not like a truly Ethereum compatible scaling solution. It's not like because like when people think scalability, they think doing everything you do on Ethereum but faster, and it's not like that. So it's a solution for Bitcoin, but Connext is not actually exactly a scaling solution for Ethereum. And instead, what we do is we very specifically make certain types of activities faster and easier, and that's any sort of peer-to-peer interaction. So let me screen share. I have a few slides that I can. So, quick payment channel review, just in case anybody isn't too familiar with it. So, rather than making every single transaction on chain, you can create this system where Alice and Bob can interact with each other just by sending side updates. This is useful in the event where Alice and Bob need to pay each other back and forth for a long period of time and for very, very frequently. And it's kind of like silly for them to do that and also continue to pay on transaction fees each and every time. So instead of doing that, what you basically do is like from like non-crypto terms, it's basically like an escrow, and then Alice sends like signed settlement instructions from the escrow repeatedly for Bob to be able to go and claim the latest amount of funds from multisig. And because Bob has this like irrevocable commitment from Alice, effectively you can consider that she has done a payment. So it's sort of like the core backbone, a bit like really, really bare bones idea behind both Lightning and Connext. So taking that, it's like kind of expanding on that. So there's rather than in the same way that Lightning works, rather than just having like a single payment channel, which every single time you set a new one up, you have to incur on-chain gas costs, things like that. Rather than doing that, you can route transactions through intermediaries, through nodes. That can happen atomically using things like HTLCs, because Connext is not just a payment channel network, it's also a state channel network. It allows for any sort of arbitrary, state transition. And what this means is that you can make it so that these types of hopped transactions across intermediary nodes can happen based on any arbitrary condition. So, for instance, a good example of this is like instead of using, a Lightning style HTLC, so instead of unlocking a payment based on like a shared secret, you can unlock a payment based on a signature from the receiver. or based on some on-chain event that happened, or based on some like Oracle data, or really anything. And there's actually like a really interesting design space here. The kinds of examples that people give are things like chess games and stuff like that, like as like the complexity that this can reach. But really, it's like what we see this mostly used for is like different kinds of conditional transfers. And so we expand outwards in that way, and then we also obviously have because this is a state channel and we can do more things in it. The other way that this expands is you can call any arbitrary on-chain on-chain contract as well with any arbitrary data. So that's actually really, really interesting because in Bitcoin and with Lightning, really the only thing you can do is a payment. The only output that you can have of a channel is a payment. Whereas in Connext, the output of a channel could be something like call the Uniswap contract, or it could be mint X and Y token. And so what you could even do is like mint a bunch of tokens in the channel. So it basically just like both parties just agree between each other to arbitrarily change balances between themselves in the channel, and then make it so that when that balance gets resolved on chain, what it's actually doing is minting the money in real life as well. So there's some really, really interesting, more complex patterns there that kind of arise. Cool. And then there's a bunch of different use cases we're working with. For the most part, what we've seen this be really helpful for is micropayments. We think conditional micropayments are like going to be a really, really big part of the new sort of like decentralized web space that we're moving towards. And there's different pieces of that. So there's like, the way that wallets and browsers interact with it. There's like social networks, so it's like things like MetaMask, for instance. Social networks and content networks. So like Send, Audius, things like that. There's like decentralized protocols like the Graph that are building on Connext and are based basically do like conditional micropayments in order to exchange like microservices. And then there's like a few things that don't really fall very strictly into that pattern. So there's Connext can also be used to communicate across blockchains. So there's nothing really that like stops a channel from being able to be deployed on any chain that looks like Ethereum or a Connext channel specifically. And there's no reason why a node can't serve many chains concurrently. And because as I mentioned here, because like you sort of have this like conditional transfer within one channel, and then that is linked to another channel because the conditions are sort of atomically connected to each other in some way, like for instance, a signature. Those conditions aren't really on the blockchain, right? Those are just happening in messages between different peers. And so because of that, that can be like on any two chains or any n chains. And then of course there's like a couple of things that like people talk about with Lightning as well, which is exchange. So there's like a couple of protocols that are building decentralized exchange stuff on top of us. Exchange Union is doing like BTC ETH swaps, for instance. And then there's like payment use cases. So that's we've seen for the most part we're not really focusing too much on things like retail payments. We think that market is just like absolutely cornered by existing incumbents, but like I think payments in places that are that don't have tons of great existing banking infrastructure are really promising. So for instance, this company is Zimbabwe. There's like a Zimbabwean bill payment processor, and they are like building a mobile payment platform using Connext. Cool. So that is sort of the end of my spiel. And then I guess the remainder of this is designed to be very back and forth. So I guess before we head into that, does anyone have any questions?
I got a question on that
Sure.
diagram you were showing of Alice and Bob. Can you sort of explain what I think on the next one it's got the more details, like what lives in this multi-sig contract there? Like what is that multi-sig contract doing? Is it coordinating signatures between both Alice's key and the Connext node? Just sort of curious what that piece is that lives there on chain.
Yeah, that's a good question. So what's really interesting is that because of the way that like the system is designed, like this is actually a really, really basic multi-sig. We use the Gnosis minimum viable multi-sig contract. There's nothing like there's a couple of things that are slightly special about it, just like as helper things, but there's nothing that's extremely like unique about this multi-sig contract as compared to anything else. And then the idea is so that's kind of like where the funds are held, and the idea is the protocol basically allows allows Alice and the node to go back and forth and figure out ways where they can come to consensus on what the latest balance should be, and that consensus is like signified by them both signing a state, and that all happens off chain. And then the only thing that's like slightly like a kind of an add-on to that is that in the event that Alice and the node can't come to consensus, we have a like other set of singleton global contracts, which are called the adjudicator contracts. And what the adjudicator does is it takes situations where communication has broken down between Alice and the node and uses like predefined logic that Alice and the node kind of agreed on. So like, for instance, in this channel, say Alice and the node said, we'll unlock X payment in return for a signature. And then after agreeing to that, so like when Alice and the node agree to that, they sort of agree to some logic on chain that governs that. And if they're not able to, if the node goes offline or they're not able to come to agreement in the future, then they can both independently go to this adjudicator contract, which just acts as like an on-chain court, on-chain arbitration. It replays the states and figures out what the next possible state could be. Alice and Bob could also progress the state on-chain if they wanted to, and then based on like what happens in that adjudication process, that adjudicator calls the contract and basically unlocks funds to the right person. So yeah, to answer your question a little bit more, like a little TLDR, this is pretty much just a normal multi-sig. Alice and Bob generate signatures to unlock funds from it, and if they can't agree, there's other on-chain contract logic that does it for them.
Okay, so we couldn't use just like a generic multi-sig in that spot. It needs to have some other logic around the Connext smart contract being able to override.
It is pretty generic. What you basically could do is we could probably like write a specification for you for like what features you would need, but pretty much what you need is just like there's one piece of like there's a couple of empty slots that you need to reserve for like basically like memory slots that you need to reserve because that multi-sig contract gets like delegate called, and then those slots get used for things. Aside from that, everything else is very standard. Like as long as the multi-sig possesses the capacity to perform a delegate call, it's fine. And that I think most of the template multi-sigs allow you to do that right now.
Okay, interesting. Okay, cool.
Yeah. So what we could probably do is like implement the channel as like a superset of whatever features you guys want in your multi-sig plus like whatever minimum requirements are there in ours.
Okay, interesting.
Hey, Arjun, Chris here. I had a question. Going back to that diagram again on how this might apply to transfers where there may be stateful restrictions on chain. So essentially, like in ERC20, I'm thinking of our ERC 1404 standard, and let's say block by block, a transfer from Alice to Charlie here may or may not be allowed on chain. So how would that restriction, or would it be able to propagate up through the Connext client and node?
Yeah, that's a good question. So you have to be a little bit careful with like stateful situations. So in the original protocol spec, the conditionality within the channel was always pure logic. So like you couldn't actually be stateful at all. You couldn't rely on any on-chain state. We've modified that to make it view logic. So basically you can read data off-chain. And we did that for things to be able to get stuff like block time or like block number and things like that. You can read any arbitrary state and you can make a payment conditional upon that state. However, if that state changes with time, the difficulty, like the one thing you have to be cognizant of is that the state, when you make this payment off chain may be different to the state in the event that like one counterparty decides not to collaborate and then you have to go to chain. So in the example that you mentioned, if you're like blocking a user transaction on chain, you could mimic that exact functionality off chain, and you could basically make it so that the off chain transaction relies on the status of like that on chain person, like individual's approval to receive that transaction. However, if a user's transaction gets blocked or something like that, and then their status changes on chain, or vice versa, and then they go to dispute, then in the dispute, the user will be able to make the transaction on chain. So that's just something to be cognizant of.
Got it. So it sounds like there's essentially some form of time lag where it's like the state on chain might not match the state off chain. Is
Exactly.
that something that can sort of grow without bound, or is there an upper limit where you would have a guarantee that within like so many blocks, things will sync up?
Yeah. So when you make the state off chain, so when you generate a state off chain, and both people have signed it, at that point it is finalized, and like that like whatever conditionality you apply there is finalized, and you can't. There's no like divergence between what's on chain and off chain, because really the only thing that you're agreeing on then is an updated set of balances from the multisig. Right, the conditionality at that point is just kind of like thrown out. The risk is if like it's like in the case that you mentioned, I don't think it's as much of a risk, but like it's like the risk would be, for instance, say you and I have a channel open with each other, and like we're updating our balances based on the size of like the Uniswap ETH DAI pool. And then you and I get into dispute because you say, you know what, the ETH DAI pool, actually the current price for ETH DAI is like $400, and I say, no, it's not, it's actually $430. And what could happen in that case is that you dispute me, and because I tried to pay, like you tried to pay me $400 instead of $430, I dispute you, and then now that starts in the same way as Lightning works. That starts a dispute timer. So now there's like X number of blocks within which we sort of need to finalize the state on chain and things like that. And within those X blocks, the price actually changes down to 400. Now, in that case, I've disputed you, thinking I would win that dispute because you had an incorrect price, and the price actually now matches what you said. So those are the kinds of cases that you have to be worried about. I think in the case that you said, it's not as much of an issue because it's like presumably like the amount of time that it's taking to make these transfers and agree on that these transfers can't be completed is much shorter than the amount of time it takes for you to like decide on whether a user like change a user status of like whether or not they should be allowed to get a transaction. Does that make sense? I don't know.
Yeah, that would be a really infrequent change.
Okay, cool.
Yeah, I guess to on that use case is like we have a token contract. It says only certain people should be allowed to receive this token, and so my assumption would be that like our Connext node would be sort of the hub there, and it would have to know what the current state of the chain is, and only like allow these transfers between different accounts if the chain basically says yes, this would be allowed to go through.
Yeah, exactly. Another way to explain it is that what happens in the protocol is like when like James and I are trying to decide how to make a state update. I propose a transfer. What I do when I propose a transfer is I like dry run the transfer on chain. I don't actually send it to chain, but I run it in what is effectively like an emulation environment. Well, kind of like sometimes I can also run it on chain because the on chain contracts are also pure contracts. We use it and we do it in an emulation environment just to be like faster. But because these are pure contracts, pure review contracts. They don't actually consume any gas. So you can send this transaction to chain and figure out what the outcome would be, and both parties do this individually to decide what they think the outcome should be. And so, like, say that I'm not allowed to send this transfer, but I want to try anyway. What I do is I don't actually send it to chain. I just say, you know what, it actually did work. Don't actually dry run it on chain. I say, you know what, it did work. I'm just going to sign the state and I'm going to send it over. and then it would get to James, who in this case is the Connext node, and he would run it on chain, and he would see, okay, wait, there's a mismatch here. Like the next state update that got sent to me and the state update that I generated are not the same. Therefore, I'm just going to reject this update. Yeah.
Hey, Arjun. Steve here. I'm a developer.
Hey.
One question about the function of the Connext node. Does it basically like store all the state and then govern like all those kind of updates? And so does that become like it seems like everything's peer-to-peer, but is that like a centralized place where you can kind of say, give me the entire state of sort of
that's a good question.
Channel?
Yeah, that's a really good question. Sort of, only sort of. So it's peer-to-peer, and everybody basically has their own copy of state. So like Alice has her entire state. The node has its entire state in the Alice node channel. The node happens to have all of the state at the moment because all of the users are connected to the node. So like the answer to your question is currently yes. It's not actually like governing the entire network. It just happens to have everybody's state because at the moment every transaction goes through it. Now when we move to a more decentralized paradigm and like you have many more nodes, it's kind of lightning style where you'll only have the state of the channels of the users that are actually you only have the state of the channels that you're actually opened that you are participating in, and that is what's true. I mean, okay, sorry. Let me take that back. You will always only have the state of the channels that you're participating in. It just so happens that the node in this case is participating in all channels.
In all channels, I see. Okay.
Yeah.
So when you start mixing channels, that.
Yeah. So when you have many multiple nodes, and if you eventually allow your users to run nodes and things like that, then your node will not have channels open with everybody. Will not necessarily be a participant in every channel, so you won't have all of the state anymore.
So are channels like defined or governed by like shared schema? Because like it sounds like in a rich state world now, like compared to like Lightning, like you're just transferring value. It's everyone knows what the schema is. But this rich state, chess versus checkers. Do all channels then is the channel defined by the schema, or how's the schema sort of come to agreement on?
Yeah, that's a good question. So there's two levels. Basically, there's like there's like what we call like so there's. This is a good question because it really gets in the weeds. So there's what we call the channel, and then there's what we call apps. And apps are basically like meta channels. They're like a sub channel within the channel. The way that it works is you have a bunch of funds in your channel, and then when you say with some counterparty, and that could be like your media counterparty, it could be somebody like many sort of hops down the line. When you decide to set up an interaction with them, what you do is you install an app. And then installing an app basically locks up some funds in the channel and then basically like moves those funds into this separate execution environment, which is governed by an on-chain contract, and like pure on-chain contract logic, and has its own independent balance and then has some way to like resolve that app. So that environment, the app environment, has abstract state. That environment is basically like the state of that environment is defined by the app that you write, and that is defined by like the on-chain contract, like the on-chain pure app logic that is a singleton that you dry run through. The channel logic at the moment only has like balances and tokens, like token addresses mapped to balances. You can also make the channel logic generalized. We just haven't yet because for the most part, the app logic itself just guarantees everything. You know what I mean? Like you have enough conditionality within the app logic that you don't really like. It's enough to really track everything as an update of balances for the most part in a channel. Now we have a few use cases coming up where that may not be the case, so we might have to generalize it at some point soon.
Okay, interesting.
Yeah, it's a really good question and with a really hairy answer.
Yeah.
I was like trying to avoid going way too deep into the weeds, but basically the way that this is all related to like Counterfactual, which is was a state channel research team and their protocol, and then like now that has been moved over into like the statechannels.org research team and protocol, and like we're sort of halfway between those two things. But the core idea is the core idea there is like as a framework is you actually don't need to, in order to build generalized state channels, what you basically need to do is build a state channel that has the ability to open more state channels within it. So basically a channel that really what it does is just like locks up funds and then updates balances based on those locked up funds. And then in that state channel, you can then install any application specific channel system. And because the lockup interaction was off chain to begin with, you're not incurring gas costs to install and uninstall many different application specific channels. You're just doing all of that off chain. Yeah.
Okay, so the idea is like you're kind of solving that base layer with like locking up the funds, and that's once that's done, you can now like you have the one use case now transferring value, balance is fine, but
exactly
does that underlying lockup mechanism doesn't preclude any other sort of update schema. It's just the mechanism of security there, which right now balances everything, but that same mechanism from the lights. Okay, awesome. Yeah,
cool.
Yeah, really cool. Definitely needed technology with lately.
Yeah, it's really, really interesting. I mean, like there's like several layers of channels that you're dealing with here, because it's like there's like the normal payment channel, and then with it you've built this like purpose-built channel that basically purpose-built payment channel that allows you to conditionally lock up value in the middle of the payment. So rather than just like sending the value, you just lock it up. And then now, because you've locked it up, you can do more abstract things on top of it, so long as those things can kind of collapse back onto chain in case they go wrong. Right. So yeah.
So you're still getting that security of the chain, and you're not having to rely on any centralized party. Although here kind of you are, because if one person runs the Connext node.
Yeah.
Sort of
exactly. It's still like it's this like interesting balance between like right now it's basically like it's censorable, but not entirely non-custodial, which seems to be an okay trade-off for most people at the moment.
Yeah, I mean, even our product, because it is censorable, the 1404 is restrictable, and there's pretty often like a God mode owner that can so that provides some flexibility, and like keys aren't use your keys, you can actually get your funds back. But what it also does is open it up to like these sort of Connect solutions. Some of these layer 2s, like a lot of the layer 2s have some trust issues, right? And there's some centralization there right now. But for us, that's like that already is the case. So that's really in the 1404 standard. I don't think it's really a drawback at all.
Yeah. I mean, it sounds like in your case, like you do explicitly want to allow for censorship, right? You explicitly want to allow for a situation where
the whole point
users can't. And so, like in that case, the trade-off's not too bad. Now, the main. So it sounds like the main. So I guess a couple of things that I'd wanted to jump into are James has sent me over like a list of like use cases that we should kind of talk about. So there's sending tokens between investors. This one's relatively simple and is very, very Lightning-esque. The only thing to note here is that in the same way that Lightning works, in order to send a transfer, you need capacity in the receiver channel. So like a user, deposits some funds, and then TokenSoft's, node also says indicates that they want to transfer to Bob. TokenSoft would also need some funds in this channel. Now, on Ethereum, this is a lot easier than on Bitcoin. Like on Bitcoin, this process is just a nightmare, because this process of getting funds into this channel to begin with takes like many, many hours. Whereas on Ethereum, in the worst possible case, it's like if you didn't already have funds in there, the worst possible case is that you could just go and collateralize it in flight, and like it basically falls back to one single on-chain transaction. And then there's distributions and dividends. So this was something that you guys have mentioned. There's good and bad things about doing distributions and dividends in this kind of a system. The bad thing is that at least the way. There might be a way to do it, but like the issue that I've kind of run into here is like at least the way that it's, if you do it Lightning style where you need to pre-collateralize every channel, then you're not really getting any gains here, right? Because it's effectively you're paying a single on-chain transaction to get money into the channel to begin with, and then like all of these channels, it's basically effectively the same as just sending the transaction to the user, because you're just doing one transaction in the channel. It can work if you're locking up these funds and doing like many dividends, or like a streaming dividend over a longer period of time. Basically, any situation where you're doing a bunch of recurring transactions, you'll see the gains. We might be able to do it in a slightly different, more interesting way, which is where And I think we'll have to think about this because I really just thought about it when I was putting this diagram together. But one thing that might be able to work is I sort of talked earlier about like the potentiality of like potentially minting an asset in the channel and then allowing that that effectively acts as a claim, and then you can put that on chain and claim like against some minting contract. And so that actually could potentially work where you just send users these claims in the channel, and then the user can at some point withdraw from the channel, and then they incur an on-chain transaction cost when they withdraw, but it doesn't happen until and unless they actually withdraw from the system. And until they do that, like they can also start sending around transfers, and that would still work. So there's a use case here where you could distribute tokens and have them be transferred between investors within your system without them needing to pay a lot of gas or pay much, or you having to pay much gas at all. And then they only incur the gas cost when they leave your system. And maybe at that point you can sort of like push the cost out to them, though it sounds like you guys are covering everything at the moment. Transfer restrictions, we just talked about that. Do that in the channel, in the actual channel application itself. And if you guys are using an on-chain like registry for that system, that's perfect. Actually, I was the concern that I had here when I was writing this was we might have to like build some like middleware within the node here to like stop this. But if you have it built into how your token works, then that's actually ideal. And then the other thing was like unit of count tokens. So James, you had mentioned maybe it's not the best idea to put whatever tokenized security that like you guys are trading back and forth into the channel itself, because the main issue it sounds like the main issue with channels in general is liquidity, right? Is like how much liquidity you have up front. And so if you use some sort of unit of account asset, you can always like mint more liquidity to yourselves. And as this like centralized owner, you just use that liquidity to allow transfers back and forth, and then then you don't have to worry so much about needing collateral to do these things. And it's a bit weird otherwise. Otherwise you need, like, if somebody Bob, the node then needs to also have 5 shares of the same asset, which is a bit strange. Yeah. And yeah, those are the use cases that we talked about. So I wanted to make sure that we got them in there as well.
So a question I had on the unit of account use case is what parties here would have unilateral control over the ability to move funds or to block their moving? For instance, the multi-sigs, I'm assuming those are 2 of 2 on-chain?
Mm-hmm. Yep. They are. They're 2 of 2 between the user and like the token soft node in this case. Was there a follow-up?
Yeah.
Sorry.
Beatrice, on mute.
Oh, right. So if they are 2 of 2, then does the Connext node in the middle have the ability to unilaterally move the tokens? I'm guessing it doesn't, but I'm not sure.
Yeah, it does not. All movement of tokens must be signed by both parties. And so like the user always has to approve the movement of the token itself. Now, in this case, if you're using a unit of account token, there is this sort of risk where it's like, on the user side, it's fine because the user side, it sort of represents the asset represents the ability for, like basically it represents the ability for the user to go and claim X amount of security token from some on-chain contract in the future. From TokenSoft side, it's a bit weird because it's like there is a potential risk that TokenSoft could collude with like a user to try to send them some more tokens or something like that, and then withdraw assets that way. And like then there would be this like accounting mismatch where this on-chain minting contract has 1,000 shares, and then TokenSoft goes and actually just like, despite the fact that there's only 1,000 coins minted for the users, TokenSoft finds ways to like inflate that, pays people more tokens, and then there actually end up being like 1,200 shares outstanding or something like that. Now this is all like on-chain verifiable, and like in this case, if that happened, you would know that TokenSoft did it because TokenSoft is the only entity holding any additional liquidity here. But that's definitely something to be cognizant of.
So along those lines, I guess, is there any like right now I know that Connext node, like if there's only listening to all the channels, has everything, but is there any sort of audit process? Or like you can always go back and find where every transaction happened, or it can get lost if like nodes sort of shut off and shut down and transaction happened there or state change happened here or there and not somewhere else?
Yeah, that's a good question. Right now we save everything. So, and like it is pretty easily indexable. It's just like a PostgreSDB, and you can just like pull every single transaction. And then in addition to that, every time a user like you can have what you could do is have like the TokenSoft node publish its state, and we could find safe ways to do this where like the TokenSoft node doesn't get like griefed or anything. But if it was doing that, you can also make it so that the TokenSoft node can be disputed at any time. So like any third party looking at that state can say, okay, you know what, I don't agree with this, or I don't like this. They can force a channel into settlement. Now we'd have to find a balance there, because it's like you don't want any third party to be able to do this anytime. Right now, the contracts say anybody who provides the state can throw a channel into dispute. So the good thing is that allows for like dispute outsourcing. That allows for this level of accountability where you can push a channel into dispute. The bad thing is you don't want to give your state to anybody, because then they could grief you and force dispute for no reason.
Yeah, I don't think anyone would do that though.
Yeah. It's just like, it's like a DOS vector, basically.
No, just kidding. They definitely will.
Yeah. It's it's like basically like a really, really expensive DOS vector then, which is really unfortunate, really annoying. So like you could like find ways to make it so that only like your regulatory oversight have access to those streams, or like only certain people have access to that data. So it's better that way. It's like a little bit safer for you.
Right. Or could you make it just actionable, like only there's some threshold on challenging?
What do you mean?
Like you said, like force a dispute channel to say, so like there's some mechanism to say, hey, that's not right what that node is doing. I want to, like, can you put a threshold there so everyone can see it? But like you said, not everyone can necessarily force you through these constant reconciliation.
Yeah, we might be able to put together a system where like you could publish the state and everyone, like no one could really dispute it. No one could really like initiate a dispute. But it is unfortunately kind of a binary, right? It's like either you allow third parties to initiate disputes or you don't. We could probably turn that off, find a way to turn that off. It's not really too difficult. Basically, we just like make it so that you guys have to like sign something when you're disputing. One of the channel parties has to sign something to initiate the dispute. But that's about it.
So you could layer on the binary side of that, like it is centralized, right? But you could layer on like other sort of mechanisms there. Like, okay, we do have sort of governance token, and if you're above a certain threshold there, you can vote and force it there.
Yeah, exactly. And we've talked to some people about doing things like giving access not to the commitments themselves. So actually this might be a good intermediary solution where like in order to dispute you need like on-chain commitments, right? These basically signed commitments between you and a counterparty. What you could do is you could make it so that the node has to reveal state, and they have to like actually give their state all of the time, and then you could do something like basically have the node put up a stake, and that stake represents like an insurance bond of some sort that you guys put up that says, hey, this is our cost of audit, and like any user at that point, if they disagree with the state that you're displaying, can say, hey, actually, I have this commitment that proves you otherwise, and then can throw your channel into dispute. And what we could do then is make it so that your stake can be slashed in the event that your A channel is disputed because you lied about your stake. So that you can actually have a really high degree of like public accountability there, because as long as that stake is large enough, you guys stand to lose a lot if you don't honestly report your state all the time.
Yeah, no, I think that actually makes a lot of sense because I mean, if you start censoring stuff, then you sort of fall like really closely back into legacy financial systems. Right?
Yeah.
Trust us.
Yeah.
But like, so at least even if it's not cheap to act, like at least having that transparency and then some mechanism of start using more of these sort of native cryptocurrency primitives or governance primitives.
Right.
So Connext is sort of the underlying structure doesn't have any opinion strictly on that. You can layer in any of that stuff. You can pay. That's really cool.
And actually, like a lot of the protocols that are building on top of it, it's like Graph, for instance, has its own like staking and slashing mechanism, and they build the staking slashing mechanism into how Connext works. So like, it's not based on like the node providing information, but it's like based on that you have payments going from like Graph, the Graph gateway, which is like where queries come from, and then like Graph nodes. And then if Graph nodes misrepresent data, like Graph nodes basically respond with signed messages, and the signature represents like an attestation and a certification that they're willing to be disputed about this, and that's it. And so like you make this payment not based on the correct fetching of data, because there's no real way for Connext to like verify that the data was fetched correctly, because the data can be on IPFS or something like that. But what we can verify is that the signature is correct, and then the signature can be used as a secondary dispute layer to dispute like a Graph node by saying, hey, this data itself was incorrect or missing or something like that, and then you slash the Graph node.
Right, and then is there a mechanism sort of similar where like it's sort of a community vote mechanism?
Exactly. Yeah.
The data should be. I mean, because it's like I'm somewhat familiar. So Graph protocol, right? That's what you're.
Yep.
Okay, so it's like basically it is like sort of data stored with a content hash, and then a sort of everyone agrees on a schema that it gets mapped to. So it should be something pretty not that hard to programmatically say, hey, this worked or it didn't. It's not like what was the weather today? Was it 90 degrees or 90 degrees?
Yeah.
0.0001. Like so,
well,
it just maps.
Yeah, I mean the core idea comes from Augur, and Augur allows you to do that with theoretically anything, as long as it's like clearly definable. Right? So as long as you can sort of like say like as long as you can very clearly say like yes or no, and there's a very clear answer to it, Augur allows you to dispute anything in that way.
So that's why maybe I'm missing something. Like Augur always seems suspect when it's like the weather on weather.com. Because like isn't that one web developer?
Yeah.
It's like what if he decides, I'm changing, and then people are like, well, that's bullshit. Obviously, obviously it's not. That's where like Graph protocol almost, because it's so decentralized, that seems almost easier and like more robust, right? Because it's just a content hash, and then hopefully a schema that was open for everybody, and it's much less. It's not one person you can get at weatherbug.com or whatever.
Right.
So something to 50.
That's fair. Yeah, that's totally fair.
Yeah, that's really cool though. Yeah, that's super interesting. Like way to do the mechanism.
Yeah, and in your case, it's basically exactly the same thing. Like you'd say the state at X time for X channel. When you publish the state, you can sign it, and like by signing it, you're saying the state at X time for X channel is this, and I'm willing to be held accountable to that. And if any user that says, hey, it's not, and disputes the channel, can then prove that it wasn't, and then slash you the same brand, the same.
So then that also necessitates a token of our own for that, right?
Yeah.
Because you can't really
token or like whatever you guys are willing to put up as a stake.
Right. And then other people
can do like a DAI stake or something like that too, a USDC stake. Yeah.
That's something else then, yeah. That's interesting. Okay. That's really cool. Is the Graph protocol's work open on that? Probably, right?
It is mostly. I think like some parts of it are and some parts of it aren't. I think you should check out their repo. I mean, it's hard. I don't know because we have access to their private repos, so I'm not sure which ones are private, which is open, right?
Yeah, for sure. I think most of their stuff's pretty open though, so I'll definitely look for. And then so the next Connext stuff would be like Solidity code then. Like what would a Connext node be written in?
TypeScript. So like it's mostly like an off-chain server, and then you have the on-chain contracts which are written in Solidity. For the most part, I think like for something like tokens, unless you were doing the whole thing where like you're minting the asset entirely off-chain and then like reconciling it against an on-chain contract, like there wouldn't really be any like Solidity code. But even the Solidity Solidity code that gets written for an app. So the apps are written in Solidity because those are like singleton pure logic contracts that get deployed on chain and then you could call them as like a dry run. Actually, here, let me show you what those look like. That might actually help. So like this is our whole like monorepo. The node itself is completely off chain, and then basically runs on TypeScript, and then connects to these contracts. So like both the node and the client is effectively just like a light node. Both of them run what is called the CF core. What we call the CF core is basically like a protocol engine, which is also written in TypeScript, and then that protocol engine interacts with the contracts and interacts with like protocol messaging. And so then as part of that, the protocol engine basically like dry runs these apps. So say for instance we want to install this like graph batch transfer app, we want to update this graph batch transfer app. This is a contract that'll be deployed on chain, and when we go to update it, we'll call this apply action function, and you pass in your existing encoded state and then an encoded action. And because this is a view function, calling this on chain won't actually consume any gas. So you'll end up going through this. You'll manipulate the state, and then you'll return a new encoded state. And so off chain, you're just handling encoded states all the time. You're performing state transitions on these encoded states based on this on chain pure logic. And then at the end, when you want to finalize the app and uninstall it, you call compute outcome. Similar thing. It just figures out what you need to do in order to get out a set of balance updates.
Okay, that's all off chain, right?
This is technically on chain, but it doesn't consume any gas because it's pure functions.
Okay, but all the when you say like the updates, like is it
Yeah.
the last part?
Yeah.
Compute outcome.
Yeah, exactly.
Would be like relevant only in the off chain until some sort of voucher or some kind of resolution where someone comes out. Okay. So
the interesting part is the dispute logic uses the same contract, right? So like the way that the adjudicator works is that the adjudicator takes in when you say like I want to dispute X application, or I want to dispute X thing. What the adjudicator does is it actually just points to the relevant. I don't know if I need to show you the adjudicator, but it just points to the relevant app logic. And then just runs the app logic, and so it's the same core logic is being used off chain, on chain. Right? The idea behind that is like it's a giant pain in the ass to write like state transition functions. It's also a giant pain in the ass to like write validators for these things. And so if you just run the same logic on chain and off chain, quite literally the same code, it just massively reduces the surface area of problems.
So like that commitment basically takes in like you said the arguments, the method of the arguments. And like what block presumably, and then this is what I would have gotten. So then anyone else needs to say like, okay, if I apply these updates on this block to this contract, it's pretty easy.
It doesn't actually take in the block number. It just takes in like the state. So you could include the block number in the state if you wanted to.
Oh, okay. Wait. Okay. So, aren't there time issues there? Like.
Yeah, so that's kind of what I was talking about earlier, where it's like if you're making a call that's stateful against the chain, then there are time issues where you have to think about, okay, you have to like do this extra step of thinking about what does it mean for me to call this contract at X time versus Y time versus Z time. Really, we've only done that for things like block number, so it's not too big of a problem, or for situations where it's like really like small changes to on-chain like logic. So it's not been a huge issue yet, but yeah, it would be an issue if you were relying on state that was changing very frequently.
Okay, I see. Yeah, okay, that makes sense now.
But yeah, unfortunately, like even if we weren't doing that, Ethereum unfortunately doesn't have, like at least from within Solidity, like within the contract bytecode itself, doesn't have access. I guess within the EVM environment itself doesn't have access to its own previous state from older blocks, and so you couldn't, even if you wanted to do that. And actually, that would be really, really helpful if you said, okay, I wish, like, I'm running this against the block, against like X block, and like I want the logic to be like based off of the state of Y contract at that block. You, unfortunately, if you got into a dispute and you reran that, you wouldn't ever be able to access that previous state just because you can't do that from within Ethereum itself.
Right.
Yeah.
Yeah, that is the one. Okay.
Yeah, it would be really helpful. Actually, I hadn't thought about that.
I mean, I guess from a legal perspective, you can still just layer the states, right? And say we all agree what the blockchain state was. We have it audited on the Connext node. You can see what happened, and a transfer should have been restricted. The Connext node decided not to because they did something dirty. So you can still do it. It's one extra step as opposed to just being able to sort of push button, hey, run this state,
Yep.
hey, return false. So it's one, the small. Okay.
And especially in the case of like a transfer being restricted and then them disputing and then making an unrestricted transfer, that would be exactly the same thing as them just like not disputing, waiting, and then making an off-chain transfer, and it would cost them a lot less money. So it's like effectively, you from a legal perspective, there's no real difference, I think.
Yeah, in our case, I don't think it makes any difference. I'm just like trying to work through, like, it's still, at least the data's still there.
Yeah.
Like, you don't want to, kind of feel icky about giving up information, but you're not giving it up. You're just, like you said, it's sort of the same thing anyway.
Yep. Yep. That was actually the next slide. So there's a question mark here because I wasn't actually sure what the parameters were around auditability in your case. I didn't know what you meant by that, but at least based on this conversation, it sounds like something along the lines of being able to have the state be publicly viewable by everybody seems like it's an important, not requirement, but something that's desirable.
Yeah, like specifically, could a regulator understand who owned what, even though funds are locked in the channel, and be able to view and verify that none of the regulatory, issues that we say we're protecting against are being violated.
Yep.
So,
yeah, makes sense.
All right. Well, on the just a time check here, we got a couple more minutes. Does anybody else have questions for Arjun? Randall, what do you think?
No questions. I think it's pretty cool as well. Still trying to understand it a little bit better.
Yeah, I guess one question I have is there somewhere that you would point us to go play with this? Like, you guys have some integrations with a bunch of stuff. Where is like the easiest place to go play with this and see it in action?
Yeah, that's a good question. Sadly, there is nothing that's actually easy to play with right now. It's taken us a bit longer than expected to get like our V2 up and running. There's like a lot of like low-level distributed systems complexity with this stuff that we've had to work through in the past few months. And so stuff like the graph and things like that are going to be going live soon. I think it's mostly just like a matter of them getting through their own processes. Once things like that are live, I can definitely let you know. But there isn't anything that's super easy right now. There's like things like Exchange Union, for instance, you could play with, but that would require. It might be interesting. It basically would require you to like spin up their like daemon locally and like play with it via CLI, but you'd be able to like swap ERC20s and BTC. It'd be pretty cool.
What's the name of that project?
Exchange Union. I'll send over a link.
Okay, cool. All right. Does anybody else have a question? Nobody jumped at it the last time I asked, so I'll give one more try. All right. Well, Arjun, I think this was a very interesting discussion from my end. I can see us sort of looking out into the future a little bit, and we know that there's going to need to be second layer stuff to solve these problems. Nobody's going to be wanting to pay $10 every time they want to do a ERC20 transfer. So
right.
I think we should continue the conversation and see. Maybe the next step is to sort of talk about like what would be the lift to get in like a proof of concept and understand what all the pieces would be there. So I think maybe we can follow up over email and get that conversation going and pull in Chris as well.
Perfect. Awesome.
All right.
Cool. Well, thank you guys for having me. Really appreciate it.
Yeah, I really appreciate you coming in and spreading the knowledge as well. So we'll talk soon.
Absolutely.
Okay.
Thanks, everyone.
Thanks, everybody.
Presentation.